the chapter, when we first started this whole chapter out, we did right triangle trig. Pythagorean theorem. So right off the bat, when you're solving sides of a triangle, we knew that had to have curve. Okay? We knew that never changed. We knew we just had to figure out what part never changed in the right triangle, what side never changed. The hypotenuse, good. So when you go through and you're working with the hypotenuse stuff, the big idea was just making sure you entered it correctly into the calculator to make sure that it works itself out. So let's take a look. What I wanted to do today was kind of go through one or two of these problems. So right off the bat, guys, I am not talking over you. One of the things I want to look at right away is I want to look right at number 2. Number 2, you have a right triangle. What part of the right triangle are you trying to solve for? A leg or a hypotenuse? A hypotenuse. Make sure you guys have your calculators with you. Yes, ma'am.
No, I actually don't. What do you have there?
I was going to say this was great.
Oh, sorry.
What part are you looking for? A hypotenuse or a leg? Hypotenuse. With all those square roots, when you're using Pythagorean theorem, what do you have to make sure that you put around the square roots? Parentheses. Okay. When you go to type this stuff in, you have to make sure you do the quantity 2 root 2 squared plus the quantity 13 square root of 13 squared equals our unknown squared. Okay. So when you type that in the calculator, again, 2 root 2 quantity squared gives you 8. 13 square root of 13 squared is 13. Gives you 21. And then when you take the square root, you get the square root of 21. The multi-view calculator will simplify it for you. Okay? The multi-view calculator will simplify it for you. And then that will just give you the square root of 21. Okay? It does not simplify it. Okay? Does that vaguely ring a bell? The second portion of that chapter, or of that first section, dealt with how do you tell whether or not you have an acute, right, or obtuse triangle. Remember, that's when we flipped the a squared, b squared stuff. We put the c squared on the left. So when you have the c squared on the left, we wrote it out 3 different ways. Oops. If c squared was smaller than a squared plus b squared, if c squared was equal to a squared plus b squared, if c squared was greater than a squared plus b squared. If it was smaller, what kind of triangle was it? It was acute. Good. All right.
Thank you very much.
No problem. So if that was acute, if it was equal, it was right. And then by process of elimination, it is. Now, one of the things that I've made note of on here, it says show your work to make sure that you're doing it correctly. So, for example, what I would do is I'm going to look at number 8. Okay. Number 8, it gives you a couple of roots. All right. Those are. Oh yeah. I'm sorry. Okay. Number 8 gives you a couple of roots. Even though you have a picture there, not always will you have a picture to be able to tell whether or not what you're looking at. Do you remember how to get decimal equivalencies of square roots? Double arrow button. Okay. So if I'm looking at 8, I've got side lengths of root 11, 2, and root 17. And sometimes I might just write them out like that. You have to figure out which one's the biggest. What you're looking for is which one of those is the longest length. So if you type in the square root of 11, you're probably getting, 3.2-ish? The square root of 17 is probably 4.1-ish. Which one of those 3 is the biggest? 17. So we just put the square root of 17 on the left, square it. Remember we put that little box in the middle for the question mark. Square root of 11 quantity squared plus 2 squared. Okay? And then it's just a matter of simplifying it out. Square root of junk squared is always junk, so you get 17. And then you get 11 plus 4, which gives you 15. Which one's bigger? Or are they equal? So 17 is bigger than 15, so it would be obtuse. That's how you show your work on these types of problems. That's exactly what we did. That's what we did before. That's what we wrote out. And it was pretty straightforward. Not terrible? Special right triangles. Special right triangles are something we spent about a week or so on. Remember, we had ratios of sides. We had 30, 60, 90, and we had a 45, 45, 90. Remember, when we wrote these out, it looked at some value of x times the square root of 3, and some value of 2x. So depending upon what problem, yes, ma'am. Depending upon what type of problem you're looking at, you have two of them to choose from, okay? So if I'm looking at number 9, on number 9 on here, across from which angle do you know? The 60. I know that across the angle is looking at something times the square root of 3. Well, that value equals, in this case, 5 root 3 over 2, which means you have to solve for x. To solve for x, you have to divide by the square root of 3. How do you get x by itself? So multi-view calculator is great. You just go to your calculator, which I don't have multi-view open, pardon me. You do your fraction bar with the multi-view calculator. Type in the 5 root 3 over 2. Do that first. Excuse me. Fraction bar, 5 root 3 over 2. Just leave it like that. I hit enter real quick so that we can store it there. I have to divide that by the square root of 3, so I just hit divide by square root 3. Hit enter. There's your value of x. It's that fast. So everywhere I see an x value now, I just put in 5 root 2. Or not 5 root 2, I'm sorry, 5 over 2. Excuse me. Yeah, if you don't mind. Or you just, you know what, just go underneath that calculator right there for me if you don't mind. Sorry. So that means that value of x is 5 over 2. So across from here is 5 over 2. Across from here would be 2 times 5 over 2, which is 5. Okay. I took 5 root 3 over 2 as a fraction bar, and I divided it by the square root of 3. Okay. If you're across from the 60, yes. Okay. Yeah, if you're across from the 60, if you're given across from the 60, yes, you just divide by the square root of 3. If you're across from the, oh yeah, I forgot to grab the square root. All right. Yes, and those are the two. Yeah. I'll do your sister. I did. And you know, I think she sat there. I think I told you that before.
That's weird.
It is weird, but I was like, oh yeah, I got you, Maria. I'm like, nope, wait, that's sorry, I'm sorry. Remember things eventually. So yeah, if you're given across from a 60, you got to divide by the root 3. If you're given across from the 90, you just get divided by 2. And then if you're given across from the 90 in a 45, 90, you would divide by the root 2. So remember the ratio of the other one. Since this was an isosceles right triangle, it was x, x, and x root 2. Okay. And they work out rather quickly as you go through them. Let's see here. Is there 45? Let's look at number 11. On number 11, are you given across from a 45 or across from a 90? 45. You're given across from a 45. Good. So that means that this value of x is 3 root 2, which means the other value of x is 3 root 2, which means here I have to take the 3 root 2 and multiply it by root 2. Again, when you do that in the calculator, you get 3 root 2 times root 2, and you get 6. And then you would fill in the blanks as far as which part you're looking for. After that, just goes right to SOHCAHTOA, which you guys obviously know what you're doing. If you go back and look through what you've done in the past, SOHCAHTOA, just you guys fly right through. Right? You guys have been flying right through the SOHCAHTOA stuff, so don't forget how you set up and solve for your angles. Don't forget to circle, draw to the opposite, and fill in the blanks and go from there, okay? It should not be so terrible, okay? The only other thing that I can say that will be on there are gonna be those elevation depression problems, but again, they're very easy. I'm assuming that there weren't too many craziness with those. It's just draw a picture and then go through it, okay? Is there a specific style of one? I mean, this stuff is really straightforward that you guys need to double check to look at.
The draw one.
The draw one, do you have one in particular that you remember from the sheet that you want to look at? Is there one of those you want to look at? Or was the one you
Number
had?
9.
Yes, sir. I know, it's one of those down plus. It's like the one time a year that's going to happen. So, question was number 9 on this one. Find the angle of elevation of the sun when a 7.6 meter flagpole casts an 18.2 meter shadow. All right, where do flagpoles? Oops, sorry. Where are flagpoles? Where do you put them? Outside. Yes, thank you, Captain Obvious. Is that the first time you've talked this whole year? Probably, yes, I am. Now, it would probably be put in the ground, right?
You're so mean.
Oh, yeah, it's whatever. Why do I want her in here?
She looks like a nice young lady.
Looks are deceiving.
Yeah, I know. I bet you. Aww.
So, wait, they dispense donuts in the restroom now?
I didn't go to the bathroom. I said I didn't. And then on the way there, I saw a friend. And he had donuts. And I was like, I need a snack. He was like, donuts? And I was like, yeah. He said, I had donuts. And I don't even like donuts. Go get a donut.
Never a dull moment. Anyway, so here, basically you're drawing a flagpole. Flagpole comes from the ground. Where's the sun? In the sky. All right? It just points.
Well, technically,
Flagpole, ground. We need the sun. Sun. The sun always smiling? This one does. Cast a shadow. Shadows lie on the ground. I know, right? Who would have thunk it? So the shadow is 18.2. Flagpole 7.6. Angle of elevation is looking back up towards it. What trig function are you going to use? Tangent gradient. You'll use tangent, find that one because you've got your opposite and your adjacent. So tangent of your angle is 7.6 over 18.2. Inverse tangent. And press a whole bunch of buttons. Okay. 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 Any other styles that we're looking through here? Yes, sir. All right. Let's see if there was one on here. We can just kind of revisit here. I really hope you don't show it.
on the donut?
Yeah. I really don't want to have to do the Heimlich again. I've had to do it like 3 times in the past couple years. Yeah. I coach my kids' baseball team, and one year it was the younger kids. This was the first, second graders. So this was 4 summers ago. I was right behind second base, right at the edge of the outfield there on the right field, and it was still coach pitch. And the kid that was playing pitcher at that time, all of a sudden just starts going like this. So I run in from right field, and I'm like, "You all right?" Hit his bat a couple times. No, there's I turn around. Sunflower seeds. He was choking on sunflower seeds, and it would happen to be one of the other coaches' dads. So got him, and then what happened again? Then there was another kid was last summer. There was a kid that was, you know how you guys think you've got a regular old boring plastic water bottle like that, like everyone has. What they did is he went and took off the cap, was holding the cap with his hand as he was drinking the water bottle, and somebody like bumped him, and he dropped the cap in his mouth and sucked the cap in. So the cap was stuck in his throat.
Oh my god. Hey, these happening.
Yeah, so we did Heimlich on him. I couldn't get it out, but one of the other dads in there was a fireman, paramedic, so he was able to get it out real quick. Learn the Heimlich maneuver, ladies and gentlemen. Learn the Heimlich. So anyway, Gio was asking about angle depression. So remember, the idea of talking about angle depression, let's see. If you happen to have, I think I did one, we can kind of make this one work. Let's say you're in a boat. All right, you're in a boat. All right, and this boat has one of those see-through bottoms for like looking at ocean wildlife. So you're in the water. Okay. This is all water. Okay.
Why is it? Okay. Great job.
Thank you. It's okay. It's okay. It's okay. Let's say that your anchor, you got the ground. Okay, so here's the ground. Your anchor dropped. So it's the anchor. Okay.
No, you look.
Hey, everyone, let's fill this all in. So let's just, now it looks like, oh, we'll put the arms out. So now it's like a giant anchor. Now it just looks like a really dead body. Anyway, so we have the anchor and the ground. All right. And let's say it's anchored down 27 feet. Just making numbers up. All right. Okay. And let's say somewhere as you're looking on the ground, bless you, you're looking at the ground through your observation thing because there's people in here looking. Like, hey, look, there's stuff. They notice at an angle of depression of 23 degrees, they see a shipwreck bounty of gold. There's a pot of gold in a pirate's chest. 23 degrees angle depression. So the question is, how far is the buried treasure from directly underneath the boat? So we're trying to figure out how far is this from the anchor?
You use tension.
Correct. But what do I do if I have 23 degrees?
You add it in.
Angle depression is looking upside down. It's also looking that up. So it's 23 here. It's also 23 here. Yes, ma'am. They're right. Lines and you just because you work on the inside of the triangle. Depression is outside the triangle. You switch it inside and it works. So then, like you said, you would use tangent. Okay, so you have your opposite, you're trying to find the adjacent. So tangent of 23 would be 27 over, what's it called, x. Change-o, change-o. So 27 over the tangent of 23. 63.61 if I go 2 decimals. The buried treasure is 61.61 or 63.61 feet below or away from the anchor. Depression is the same thing as elevation, just inside the chart. Okay. You guys should do really well at this stuff. Yes, sir. 23. They're both 23. Just the 3 just might not have looked that well.
Got it. I think I got all the numbers and it says 15 now. Yeah.
That better. That means I have to make sure it's printed off.
What? I'll take it. I mean, I'll get it.
So use the time now. Work on that review stuff. Like I said, I'll put some stuff, and you guys should be able to knock this stuff off. Okay.
Easy. Easy peasy, lemon squeezy.
I'll take care of that.
Oh my God, that's great. I'm making what's wrong with
What's that?